Hello and welcome to a new video where today we're going to be doing quicksort. Well, I'm going to be showing you how quicksort works and then how to implement it in Python. In the description though there will be a link to a GitHub with other languages that I've done all of the algorithms in as well, just in case you want to see the code in your preferred programming language. Quicksort comes up in both A levels and GCSEs, and I'm probably sure other corrections internationally. It is a very common algorithm in computer science. It has the best case of O(n) log n and the worst time case of O to the n squared, so a polynomial, quadratic. So how does quicksort work? We choose a pivot item to start with, and you generally want this item to be roughly midway in your data. However, it's not sorted, so we don't know where that is yet. So if we're going to be slightly lazy, or make our life easier, we're just going to pick the first or the last item. So let's say we pick 3, and I'm going to make this green, just to make my life easier. And we're going to put this just there in the center. Move this 9 out of the way. So now we've got our pivot, we're going to want to split our data into everything that is smaller than it and everything that is bigger than it. So we'll say 2 smaller, 11's bigger, 4's smaller, 5 is bigger, 4's bigger as well, 9's bigger, 7 and 16 are all bigger. So that wasn't a great first sort, but that's just sometimes how it works out. So we'll move this up and we'll put that there. Now we've got 2 more lists. So 2, but 2 is just on its own. So we can deem this sorted and we can put this in our sorted group. So we'll put that up to the side as well. 2 and 3. So they've first been sorted. Next we will pick our next pivot, generally the first item again. So let's make this green. And now we're going to do the same, where we're going to sort everything to be what is bigger and smaller. So 7, 16, 11. There we go. This can't be split into any more groups, so we will put them up as say they are sorted. Let's pick this one to be our pivot now, just change up a bit. So we'll put 11 down, and that is our pivot. 9 is smaller, 7 is smaller, 16 is bigger. So these two are sorted, but they are greater than. And here we'll pick 9 to be our pivot, 9 will be pivot, and green, or 7 is smaller, so then that goes down, and these two are sorted. And now as you can see, by going through our lists, everything becomes sorted when we move it up into one big list. This is sorting by pivoting. This is a recursive algorithm. So let's now implement this in Python. So first thing we're going to do is we are going to get ourselves some data to sort. No one wants to see me write out array, so there we go. We'll put that one in there. The next thing we're going to do is we're going to define a function. We're going to call this quick, and we're going to pass an array into it. You can name it whatever you want. We are then going to check if the list of data we're left with is less than 2, so 1 or 0. So we're going to do if len of array is less than 2, because at that point it is already sorted, and we're going to return the array. Otherwise, we're going to want to start splitting it into our groups. So we're going to create ourselves a pivot. I'm going to be lazy, and I'm going to say that this is equal to our first item. We're then going to want a list of everything that is less than the pivot, and a list of everything that is greater than the pivot. That's how you spell greater? I think so. Now we're going to loop through the data, but we're going to be starting from the first item onwards. I put one too many square brackets in there. And this is because we want to skip our 0th item, which is our pivot. So if I is less than or equal to pivot, we're going to say, we're just going to append that to our less list. So less.append I. And now we're going to say else. If it fits in the else, it has to be greater than our pivot. So we're going to do greater.append I. So that will be our first pass. But this is a recursive algorithm, so we're going to then return. And now this is where it takes a bit more thinking about, but I think it's quite a neat trick. We're going to return our quick algorithm of the less items plus the pivot plus, and then the quick sort of our greater than items. So if we now run this, print, and then we're going to go quick, and then we're going to go data to sort, and we're going to run that quickly. There we go. So as you can see, it has been sorted. What we're doing here is we're now creating up 2 more instances where we're sorting everything that is less than our pivot and everything is greater than our pivot, like we did in the demo with the cards.